Welcome to another tutor short provided by the Educational Support Services Department of Lehigh Carbon Community College in Snexville, Pennsylvania, which is just outside of Allentown. These videos review key learnings for the science courses provided here at lccc. And please remember that the Educational Support Services Department does provide walk-in tutoring 5 days a week. Let's review the types of chemical reactions. The ones shown here are the ones presented at the lccc course of Chem 106. If we still have the same textbook, it'll be Chapter 5. But the types of chemical reactions that are presented, these 5 types here, we'll walk through them one at a time, but they're fairly straightforward, shouldn't be too difficult to understand. Combination is the first type of reaction. You take two elements and combine them into a molecule. So as an example, let's take calcium plus chlorine. And remember, chlorine is one of the diatomic gases, so it'll always exist in nature as Cl2 if it's by itself. So this is your A and your B is chlorine, and you're going to combine it together, calcium and chloride. You're going to form a molecule here of AB. The second type of reaction is just essentially the opposite. Now you're going to start with a molecule and you will decompose it into its constituent parts. So as an example, let's take ferric sulfide, so it'll be Fe2S3, and we're going to decompose that into iron and sulfur. In this case, you'll form 2 irons and 3 sulfur. So that's a decomposition reaction. Now for the next reaction is a single replacement. You'll see here the example is AB plus C going to CB and A. So the one of the elements is switched in the molecule AB when you move across the equation. So for an example there, and I'll try to use the appropriate colors here, we'll have as an example, let's take 2 silver nitrate. So silver Ag, the nitrate NO3, and we're going to add to that, let's take copper. So you have here, you have your A and your C are going to switch places, and so you're going to make copper nitrate on this side, NO3 2, and then you'll see you'll have 2 silvers. So again, silver and the copper switch places, single replacement, mainly because you look here, copper is by itself. In double replacement, it's a similar reaction, only now, for example, the copper up here would also be in a molecule by itself. So as an example here, let's use, I'm going to take barium chloride, which is BaCl2, and I'm going to react that with potassium sulfate, SO4. And again, the A and the C compound are going to switch, and we will get over here, going to get 2 K potassium chlorides and a barium sulfate. Barium we showed in red, and go back to sulfate. So it's similar to the single replacement in that, you know, the potassium and the barium are switching, but now because you have chlorine and sulfate here, it's a double replacement, whereas the one above, copper was by itself, and you ended up with silver by itself, and that's a single replacement. And then finally we talk about the combustion reaction, which is, if you show here, an organic molecule, CH, some form of CH or combination. It will be reacted with oxygen, a diatomic, so it'll be O2, and you always generate CO2 and water. And so, as an example, we'll just take, let's use this. Let's just take methane, CH4. And when that reacts, you'll see you'll need 2 oxygens in order to make CO2 and water, and you'll make 2 waters. So if you see an organic molecule and that the problem tells you it's combustion or it says reacts with O2, you can expect to generate CO2 and water. Straightforward combustion reaction. Thank you.